In the last video, we introduced how circular motion relates to gravitational field. In this video, we're going to be introducing a new concept known as geostationary orbits. We have specific satellites on planet Earth that are used for telecommunication transmission, right? So that's radio, television broadcast. And a satellite, as you're seeing in the image above, is basically an object that is sent into space to allow for communication to occur with planet Earth. Now, the satellites that we're going to discuss in this topic are known as geostationary orbits. Very important satellites that you need to understand as you'll be studying gravitational fields, and they have three specific characteristics that we'll be exploring. So the first one is that it remains directly above the equator. So the equator is basically a line that cuts the Earth into like two halves, if you will, right? So something like this, we can say that's the equator, that red line over there. So a geostationary orbit will always be above the equator. It never moves away from the equator. So it remains above the same point, which is just above the equator. So you can easily say it's stationary. That's why it's geostationary. It's logged within a specific area. So it's one of the characteristics of a geostationary satellite. It remains above the equator. It moves from west to east, which is the same direction as the spin of the Earth. So it moves from west to east, west to east, west to east. So that is how it moves. So it's sort of like rotating like that, right? West to east, west, east, west, east, west, east, west, east. As it's moving about the equator. So that's another characteristic. And then there's an orbital period of 24 hours. So it takes 24 hours to complete this journey, the journey around the Earth, right? So essentially it takes 24 hours to complete that journey. And in order for me to understand all these different points, right, I created an acronym known as WEEP, right? So west to east, that's essentially WE. Then E means it's an equatorial orbit, always above the equator. Then that P is the period of 24 hours. So if a question asks you, explain what is meant by a geostationary satellite, you can easily just say WEEP. It's a satellite, it's an orbit that is from west to east. It's an equatorial orbit. And an object in that orbit, we have a period of 24 hours. So that is what a geostationary satellite is. It's a satellite that's geostationary, that's logged above one specific point, which is the equator. It's a satellite that moves from west to east, the same direction as the spin of the Earth. And it's a satellite that is an orbital period of 24 hours, which is also an important concept for you to be thinking about. So that is what you need to know about geostationary satellites. There's really a lot of things about this. A lot of assumptions that you need to make is, for example, if it's a period of 24 hours, you can be asked to make certain calculations by relating to this equation that we derived over here. Right, so if they give you and say it's a geostationary satellite, you'll now know that, okay, the period is 24 hours, so that's good. You've given the mass, you can find the radius of the geostationary orbit. But other than that, there isn't really much that is required of you to know underneath this topic. I hope this was helpful. I'll catch you guys in the next video.